Hi students, here we are continuing the trigonometric chapter 11.4 exercise number. This is the last exercise of this chapter. After this we'll start new chapter. Okay, so we have next problem number 2. In the previous lecture video we have solved 3 questions of the problem number 1. Now here we are going to solve problem number 2, where they have given show that cosecant theta, that is cosec minus cot theta square, cosecant theta minus cot theta square is equal to 1 minus cos theta divided by 1 plus cos theta. This is what they are asking to prove. Okay, so here in this problem we can start with the LHS part, that is cosecant theta minus cot theta whole square, and in place of cosecant theta we can write here it as 1 by sin theta. We know that cosecant theta is 1 by sin theta and cot theta is nothing but cos theta divided by sin theta. This you have to remember. Okay, cosecant theta is equal to 1 by sin theta or sin theta equal to 1 by cosecant theta. Both are same. Similarly, cot theta here we have, that is equal to cos theta by sin theta, whereas tan theta is equal to sin theta divided by cos theta. So here we have cot, so cot is replaced with cos theta divided by sin theta, and cosecant here is replaced with 1 by sin theta, and whole square it is there, that we have written as whole square only here. Right, now we can take the LCM inside this square. Inside the square we keep the square same, and inside we take it as sin theta as the LCM. So LCM when we take, we have 1 this sin theta which is in the denominator and this sin theta. So this sin theta divided by this sin theta, it is equal to 1. 1 into 1 we get it as 1. So that is for the first term we get it as 1, and for the second term again this sin theta divided by this sin theta, it is 1. 1 into this cos theta, it is going to be cos theta, and here we have minus, that we write as it as minus. And as I said, now this sin theta in the denominator divided by this sin theta of the second term, so sin theta divided by sin theta, it is going to be 1, and that 1 into this cos theta, that gives it as cos theta. Now we can take this square for the numerator also, 1 minus cos theta square divided by sin square theta. 1 minus cos theta square divided by sin square theta. And we know that we have sin square theta plus cos square theta, this identity we have, sin square theta plus cos square theta is equal to 1. And if you take this cos square theta on the right hand side, we have sin square theta is equal to 1 minus cos square theta. Okay, so sin square theta can be replaced with 1 minus cos square theta, and this 1 minus cos square theta we can take it as 1 square minus cos square theta, and we can write this, we know a square minus b square is a plus b into a minus b. So here suppose we take it here 1 square as a square, cos square as b square. So a plus b into a minus b means 1 plus cos theta, 1 plus cos theta into 1 minus cos theta we get. So we have 1 square minus cos square theta in the denominator, that is we replace this sin square theta first with 1 minus cos square theta, then that 1 minus cos square theta is replaced with 1 plus cos theta into 1 minus cos theta, right? So in the numerator of the given problem, this one, we have 1 minus cos theta whole square, 1 minus cos theta whole square. So that we write it as usual 1 minus cos theta whole square. In the denominator we have sin square theta. This one we have sin square theta. Thus sin square theta first we replace with 1 minus cos square theta. Okay. First the sin square theta is replaced with 1 minus cos square theta using this identity here we have. Okay, this identity we have here, sin square theta is equal to 1 minus cos square theta. Now in the denominator of this numerator we can write it as 1 minus cos theta whole square, means 1 minus cos theta, it is repeated 2 times. So we can write it as 1 minus cos theta into 1 minus cos theta. And the denominator here we can write it as 1 minus cos square theta, as we have seen earlier, that can be replaced with 1 plus cos theta into 1 minus cos theta. So we can write it as 1 plus cos theta into 1 minus cos theta. You can write 1 minus cos theta into 1 plus cos theta. It is one and the same. Now from numerator 1 minus cos theta and denominator 1 minus cos theta will get cancelled, and we get 1 minus cos theta whole divided by 1 plus cos theta we get. So this is what they have asked in the problem. This is our RHS. Okay, hence we can write that it is shown. Okay, LHS is equal to RHS, that is we can, hence it is shown, hence it is shown as required. You can write, hence it is shown as asked, you can write. Okay, this is problem number 2 of exercise 11.4. Next we will go for another problem. Okay, that is problem number 3. Here they asked, show that square root of 1 plus sine A. So A it is, or theta or B, all represents the angle only. So it is sine theta or sine A or sine B. Don't worry about which alphabet it is or which symbol. Theta, it is angle representation. As we have seen just now, they have asked in terms of theta. Now they are given as root 1 plus sine A. In place of A angle, they can ask 1 plus sine B, 1 plus sine C, D, any alphabet, X, Y, Z also. You need not to worry at all. It is same as some angle theta. So A, B, C, D or X, Y, Z, any alphabet they ask, there is nothing to worry. You can consider that as angle theta and you have to follow this. Okay. Don't confuse and don't fear of which alphabet they ask what is the problem. All represents the angle only. Okay. So here we start with the left hand side, what they have given. That is, left hand side is equal to square root of 1 plus sine A divided by 1 minus sine A. This is what the LHS given. And now what we are going to do is, we are going to do the rationalize the denominator. Earlier also we have seen this type of problem. Rationalize the denominator. Rationalize the denominator means we are going to multiply and divide this term with 1 plus sine A. What they have given in the denominator, it is given as 1 minus sine A. Rationalizing means we are going to multiply numerator and denominator with 1 plus sine A. That is called as rationalizing. Okay, we will write here the step. What they have asked, 1 plus sine A, this is they have given. In the denominator they have given as 1 minus sin A. We are going to do the rationalizing. That means we are going to multiply and divide with the opposite sign of 1 minus sin A, that is 1 plus sin A. We multiplied, as well as we are going to divide with the same 1 plus sin A. That means there will be no effect on the given given terms. That is, suppose here if we multiply with 1, so there will be no change in 1 plus sin A by 1 minus sin A into 1 represents it as 1 plus sin A into 1 minus sin A only. So in place of this 1, we can take it as 1 plus sin A divided by 1 plus sin A. So it is, if you cancel, it will be 1. We are not going to cancel here. We are writing extra terms here in place of 1, so that we can simplify the given and we can show that it is what they have asked. So we are writing this extra terms of 1 plus sin A by 1 plus sin A. So now what happens here? In the numerator we have 1 plus sin A into 1 plus sin A we have. So that we can write it as 2 terms of 1 plus sin A. So we can write it as 1 plus sin A whole square. 1 plus sin A whole square. In the denominator we have 1 minus sin A divided by 1 plus sin A. So 1 minus sin A into 1 plus sin A, we can take it as A minus B into A plus B. A minus B into A plus B. Here A is 1, B is sin A. A is 1, B is sin A. So A minus 1 minus sin A is A minus B. 1 plus sin A is A plus B. So what we get already in the earlier problem, and again earlier videos also we have seen, A plus B into A minus B or A minus B into A plus B, it gives it as A square minus B square. So it is nothing but 1 square minus B square, it is nothing but sin square A. Right. Now we seen the identity earlier that 1 square is nothing but 1 minus sin square A. So here this, in this problem, here 1 minus sin square A can be written as cos square A. Remember this. It is similar to sin square A plus cos square A is equal to 1. So we can write 1 minus sin square A is equal to cos square A. So the denominator of 1 minus sin square A can be replaced with this cos square A. Okay. So square root of 1 plus sin A, already we have 1 plus sin A whole square. In the denominator of 1 minus sin A into 1 plus sin A, we say are 1 minus sin A into 1 plus sin A, when in the same multiplication. We got 1 square minus sin square A, that we can replace with cos square A. Okay. So cos square A we are going to write in the denominator. Okay, cos square A. So now what is the step? Inside the square root we have 1 plus sin A divided by cos A. Both numerator and denominator have the same power 2. So we can write as a single term 1 plus sin A divided by cos A whole square. Now this square and square root will get cancelled. This square and square root get cancelled and we get 1 plus sin A divided by cos A. Now suppose we write this 1 divided by cos A separate, sin A divided by cos A, because in the numerator we have two terms, 1 and sin A. In the denominator we have only one term, cos A. So for the numerator two terms individually, for 1 also we can write the denominator cos A, and for sin A also we can write it as denominator cos A, right? And we know that 1 by cos A is equal to how much? How many of you remember it? 1 by cos A. Pause this video and you can think. 1 by cos A is how much? 1 by cos A we can write it as secant A plus Sin A by cos A is what we can replace with. Sin A by cos A can be replaced with tan A, right? This is what they have asked. This is our RHS. So we can write that, hence it is shown what they have asked. Okay, this is problem number 3. Another problem 4 will solve and we'll stop in this video. Next video will continue. Further we have the problems in this exercise. So what they have asked in the next problem number 4, show that 1 minus tan square A divided by, okay, cot square A minus 1 is equal to tan square A. This is what they have asked to show, that 1 minus tan square A by cot square A minus 1 is equal to tan square A, and they have given the angle A is greater than 0. Earlier also it is, and less than 90 degrees. For this condition of angle A only it is valid, can be verified, right? So we start with here the LHS means left hand side. Okay, what they have given, 1 minus tan square A divided by cot square A minus 1, right? So here tan square A can be replaced with sin square A by cos square A. Okay, you can get a doubt that how we decide where to start. So you can see the right hand side here, they are asking it as just tan square A. Okay, so tan square A when they are asking, so if you able to change the tan square A of left hand side in terms of sin by cos, and the cot square A, sorry I have written it as cos square, it is cot square, the denominator cot square A minus A, this also in terms of cos by sin square. So later after 2-3 steps we can bring it in terms of sin by cos, then we get finally the right hand side. So you should think for some time, so how to solve, or you practice more number of times, you can do the problem by looking at it. So 1 minus tan square A, we can write it as tan square A, we can write sin square A by cos square A. Okay, because we know that tan A is sin A divided by, what it is, sin A divided by cos A. Tan A is nothing but sin A divided by cos A whole square they have asked, so we can write it as sin square A divided by cos square A whole divided by cot square can be written as cos square A divided by sin square A. Just before the problems we have seen, tan A is written as sin by cos, cot A can be written as cos by sin. Okay, directly writing here, you have to memorize this relations. Okay, and we know that what is the relation between tan and cot. What is the relation between tan and cot? I have given some time. Okay, tan and cot is, tan A is nothing but 1 by cot A. Okay, so this cot square A is replaced with cos square A by sin square A minus 1. Now we are going to take the LCM. In the numerator we have this 1 minus sin square A by cos square A. In the denominator we have cos square A by sin square A minus 1. So we are going to take separately the new LCM for numerator as well as LCM for the denominator terms. Okay, so there is little gap you have to keep, because in the numerator we have numerator and denominator again, and the denominator also we have numerator and denominator. So first we are writing the numerator cos square A. Cos square A is the LCM here, cos square A is the LCM, and here we have 1 by 1, it is 1 only. So as we have seen earlier also, cos square A divided by 1. Okay, this is how you have to solve. Cos square a divided by 1 is nothing but cos square a. And that cos square a into this one, we get it as cos square a minus, okay, we write minus sin square a by cos square a here we have. So we have taken the LCM as cos square a. So this cos square a and this cos square a, if you divide, it is 1. 1 into what here we have in the numerator, sin square a. So 1 into sin square a, we can write it as sin square a whole divided by, again we have LCM for the numerator. So sin square a is the LCM, and we know that is simply we have to remember this sin square a divided by this sin square a, it is 1. Okay, sin square a divided by sin square a is 1. That 1 into this cos square a, we get it as cos square a. Okay, cos square a. And here we have minus 1. So 1 by 1, as we have done in the numerator, same 1 by 1 we can take here. And this sin square a divided by 1, we get it as 1. 1 sin square a divided by 1, we get it as sin square a. Sorry, we get it as sin square a. This sin square a we are going to write in the numerator. Okay, so we got here sin square a. So if you observe carefully this ratio, here we have cos square a minus sin square a. Here we have cos square a minus sin square a. So these two which have done with the green color, we can get cancel these two. We can cancel these two. Okay. So cos square a minus sin square a cancel. So what we left further is cos square a in the denominator of the numerator, sin square a in the denominator of the denominator. So this sin square a goes into the numerator, this cos square a comes in the denominator. Okay, it became more clumsy, I am just erasing here. So this sin square a, we can take this as in the numerator. This cos square a, we can bring it comes in the only denominator. Okay, in the this position, this sin square a goes above the red line. Okay, so we can write it as sin square a which gone into the numerator, and this cos square a comes in the below red line, that is cos square a. Now how we can write this sin square a by cos square a? Sin square a by cos square a, we can write it as tan square a. Okay, so this is what the RHS they have asked. So what we can write, LHS equal to RHS, so we can say that hence it is shown. Okay, so these are the three problems which we solved in this class. We'll stop here. Now just want to tell you here, this square, it is in the beginning of the video, I think I have said it as square root. This is nothing but square only. Okay, thank you for watching, and as usual I say that please subscribe and share so that other can also watch. Thank you very much. We'll stop here.